Now find the derivative of f of theta equals 1/4 sine squared of 2 theta. All right, so it looks like this is a chain rule problem because we could write this as a composition of two functions. And the chain rule says that the derivative of f of g of x, the derivative of a composition of two functions, is equal to the derivative of the outer function f evaluated at the inner function. Let's make that a little bit smaller. Evaluated at the inner function times the derivative of the inner function. Now, in this problem, we're actually going to have to apply the chain rule twice because we have three layers of function here. So we've got f of theta, and I'm going to rewrite this slightly differently. So that's 1/4. And so another way of writing the sine squared is like this. So we have the sine of 2 theta squared. So when we take the derivative, when we apply the chain rule, when we apply the chain rule, we start with the derivative of the outer function, the derivative of the square. Okay, so we have a 1/4. The 2 comes out front, drops by 1. Inner function stays the same, sine of 2 theta, times the derivative of the inner function, the derivative of the sine of 2 theta. Now, when we take the derivative of the sine of 2 theta, now we have to apply the chain rule again because we have this outer function, the sine function, and we have this inner function, the 2 theta. So, f prime of theta, well, the 1/4 times 2, that's going to be 1/2, times the sine of 2 theta, times, all right, so we've got the derivative of the sine of 2 theta. So let me just write this in a different color. So now we want to apply the chain rule here. Derivative of the outer function, the derivative of sine is cosine. Okay, inner function, the 2 theta. Oh, no, didn't mean to do that. Inner function stays the same, so the 2 theta stays 2 theta, times the derivative of the inner function. The derivative of 2 theta is 2. All right. So it looks like the 2 and the 1/2 cancel. And so we have f prime of theta equals the sine of 2 theta times the cosine of 2 theta. And now we could condense this a little bit if you want. So it looks like this is very close to the double angle formula for the sine function. So the double angle formula says sine x cosine x times 2 is equal to the sine of 2x. So we need a 2 out front, and to balance that off, we need a 1/2. So if we sort of multiply by 1/2 and 2, that's the overall net change is nothing. So we can rewrite this as f prime of theta is equal to 1/2 times the sine of twice the angle. The angle was 2 theta, so we now have a 4 theta. And so 1/2 sine of 4 theta, that is as simple and as condensed as we can make this derivative. And so we apply the double angle formula. Okay, that does it for this one.